Good morning, good afternoon, good evening to wherever you are. Thank you for joining today's session. And in this Tech Talk, we'll dive deeper into one of the newly launched services at reInvent last year, Amazon EMR on EKS. Just a brief self-introduction. This is Xinwang. I'm part of the AWS Containers go-to-market team, and together with me today are Peter Dabunjan and Saravana Sasiramurthy. So here's the agenda for today's Tech Talk. At the beginning, I'll start with a high-level introduction about what Amazon EMR on EKS is, and we'll also talk a little bit about the benefits you will get out of it. And I will hand over to Peter, and he will talk about the architecture design, and also he will show a small demo about how to use EMR on EKS. And in the next section, Saravana will share those best practices you may want to consider when you implement running Spark workloads on Kubernetes. And then let's get started. So as you may hear from your peers or may have seen across the industry, many of those fastest growing companies are data-driven. Oftentimes, we do see data could be the solution to solve those business critical problems, but it could also be easily getting overwhelmed or challenging to manage those. Like as the data continues to grow, you may have many data sources to manage. It could be the clickstream data coming from your website, or you may collect data from the social networking softwares. And also another challenge comes from the persona management. On one side, you want to make sure the data is secured. The person like working on the team could only access to the data they need. But also on the other side, you want to make sure the team members could work collaboratively whenever they need to work on the same project. And also another challenge coming from those real-time analytics, as you may require from your application, you want to extract the data insights whenever the data is received. On top of those, we have seen like Apache Spark is becoming more and more popular, and a lot of companies are using Apache Spark as a de facto big data engines to solve those challenges. And on top of that, we also see like many companies are running Apache Spark on Kubernetes, and there are many reasons leading to that decision. So on one side, you want to leverage those native design coming out of Kubernetes. It could be the scalable auto-scaling and also the multi-tenancy design. So you could build the application shared by different teams, by different personas, and also could be connected by different microservices. And also on the other side, nowadays, big data processing is not a silo project anymore. You want to leverage some other open source projects as well. Oftentimes, we see customers or companies are using Airflow together with Spark to solve those big data ETL pipeline orchestration challenges, and also Kubeflow as one of the most popular machine learning platform built on top of Kubernetes. We often see customers are using Spark as for the upstream data processing and Kubeflow as for the downstream machine learning. And because of those reasons, we launched Amazon EMR EKS. As you can read from the name, Amazon EMR EKS brings the power of both services into a consolidated offering. So you can run Apache Spark on Kubernetes in a much easier and also more manageable way. So here's some high-level benefits about what you can get from EMR on EKS. As you may have used before EMR on EC2, so it holds true for EMR EKS as well. EMR Spark runtime provides optimized performance. So based on the TPCDS benchmark, it runs 2.4 times faster, which translates to almost 2/3 of cost savings. So it definitely helps you to reduce the cost from that perspective. And also, as you can read from the diagram to the left side, on the compute backbone layer, you could also leverage either use Amazon EC2 to gain more control and flexibility, or you can also use AWS Fargate if you prefer to have a serverless experience. And also, if you have EKS clusters spin up across multiple availability zones, you could either submit your job on a single AZ or across multiple AZs based on your job's requirements. So those are some like high-level benefits, but how Amazon EMR or EKS could solve your problems if you're sitting on the different teams. So for example, if you're part of the DevOps team or the cloud infrastructure team, you may want to build a platform for your internal data team. So like you may worry about the auto scaling, patching, upgrading if you want to use open source Apache Spark. So because EMR EKS as a fully AWS managed service, so all of those things are taken care of by AWS. So you don't need to worry about those. Even though like for the upgrading, you probably still need to specify when to upgrade and which version to upgrade to, but it may just take a couple of clicks away. And also beyond the compute as a DevOps team, you may also think about like networking policy, the storage consideration, and because EMR EKS as a managed service, it's well integrated with the rest of AWS platform. So you could use different storage options, the KMS, and also other services provided by AWS platform. If you're part of the data engineers team or the data scientist team, you may want to also provide much better performance for your running your Spark workloads. As we said earlier, so EMR EKS provides 2.4 times better performance. So you don't need to spend time to turning your parameters or like optimizing your application. And also one thing we heard from customers talking about when they're using EMR EC2 about the cold start time. But now if you have a running EKS cluster, it may take less than a minute to spin up a pod or a new node based on your job queue. And also you could create different namespaces for different teams to make sure the data is isolated and secured. Or if you're part of the C-level team, cost and security are always top one concern for your perspective. And we actually did a relatively innovative way for EMR EKS. We charge per job based on the request receipt use and memory. So if you don't have any jobs submit over the night, EMR EKS doesn't charge extra. And also because you are consolidating the compute infrastructure by merging your big data workloads with other microservices, it definitely helps you to achieve much higher resource utilization. And for the security perspective, so Ravenna will talk a little bit more about the security design baked into EMR EKS in the next session. So that's about the high-level introduction. And now I'll hand over to Peter, and he will talk a little bit about how to get started.
All right. Thanks, Zing. So before I touch on how to get started with EMR and EKS, I just wanted to do a quick touch on how does EMR and EKS compares with the previous version of EMR, right? So if you've been running Spark using Amazon EMR, it makes use of EC2 in order to provision the infrastructure, manage the lifecycle of your Spark distribution. And that's what we call here as a cluster-centric model, right? So let's say if you want to run Spark 2.4, you need to go to EMR, call the API or CLI, and EMR provisions the entire infrastructure for you with the control plane and the data plane, all of that, and makes it available for you. And you can go and run your analytics on top of it. Once your job is done, then you can tear down the cluster, right? So now imagine if you need to run multiple versions, if you need to run 2.4 and 3.0 simultaneously, you need to provision multiple clusters for that purpose, right? So when we look at the newer capability that's coming out of EMR, which is Amazon EMR and EKS, so here we see that it is what we call as a job-centric model, right? The difference is because EKS cluster is already available for you, maybe you're running microservices on top of it. Maybe you're running other machine learning jobs on top of it, right? So you could you could just create an EKS cluster one time and make your EMR, create a virtual cluster, which I'll, talk in the next few slides. Have that integration built with Amazon EMR, and once that is done, then you can go and run your Spark jobs on demand or on a cyclical, like a periodic basis, right? So this is what we call as a job-centric model. So in the previous version, or if you use Amazon EMR and EC2, it makes use of Yarn in order to build a cluster. Here we make use of Kubernetes native integration. And the advantage here is, Spark was made available from EMR back in 2015, if I'm not wrong. And the EMR team has done a ton of optimization since then, right? So there's a ton of best practices that they've collected. Our largest customers who run on AWS run using Spark, using the EMR. So you get all of those benefits when you run EMR and EKS, right? So you get the optimized version of Spark distribution. You can pick and choose which versions you want for your analytic cycles, and we go and provision those Spark distributions fully automated, and make the take control of the life cycle for you. And it also gives you two main capabilities. One is you get faster deployment. So because the cluster is already there, you get to go and deploy your Spark analytics and run the job. And once that is done, it gets teared down. And the second thing is upgrades. If you wanted to do upgrades, if you have a continuous real-time analytics, and if you need to do upgrades, and that's also completely handled for you. So here's what we talk about if you wanted to run, when you want to compare EMR and EC2 versus EMR and EKS. See that you needed to deploy 3 different clusters. If you need a different type of versions from EMR, or could be Spark versions as well. But if you look at on the right-hand side, which is EKS, you could run like a multi-tenant environment within your Spark as well, right? So you could run 2.4 on the side with 3.0 if you need to. And you could run microservices and other pieces of workload, like I mentioned earlier. So let me just walk you through how does it look like in terms of getting started. So the first thing, like I mentioned earlier, is you need to have an EKS cluster ready. So you could go, if you're an analytics team, you can go and create this EKS cluster. So once that cluster, if you go and click a button using the console, or if you run a command line, what we do is we go and build a highly available control plane for you, which is, it spans multiple AZs, and it has IAM integration built in. It sets up a load balancer. So all of this is handled. You don't even see this on your console. And what you get is an endpoint which has essentially Kubernetes, right? Kubernetes upstream, because EKS is upstream Kubernetes. So you get that endpoint, and then you have to go and provision a set of worker nodes. So this is the data plane. This is where your workloads are going to run. So you go provision that worker node and have those worker nodes attach your EKS cluster. Now, if you use EKS CTL, all of this is automated for you. Then a single command line. I'll show you in the demo in a few minutes. If you use EKS CTL, it takes care of provisioning the control plane and creating the worker nodes and having those worker nodes join your cluster. So all of that is automated. And once that is done, then you go and register that EKS cluster with EMR. And after that step, there's a few steps that are involved in the middle. Usually you have to do a few IAM steps, and then you can go ahead and submit job. And once those jobs are done, they will automatically be teared down for you from EMR. So here's another view of the same steps that I mentioned. I mentioned I was using EKS ETL. You don't have to use EKS ETL. If you're familiar with using Terraform or CloudFormation, you can use those same steps in order to create an EKS cluster here. And then you have to do some IAM-specific tasks, like enabling your EKS cluster so that EMR can have access to it. And then you have to enable IRSA, which is IAM role for service account, which is actually a required component. So whenever you spin up your job, only your jobs can assume the IAM roles that are being created for you. That is actually the job execution role, which you see there next. Each jobs can have different permissions, right? So all of that is built in, and it's you can easily manage those. So after that, you just go register your virtual cluster and then submit jobs like I showed you earlier as well. So here you can see if you're a multi-tenant user, right? So you can also see difference in separation of duties. So if you have an EKS operator, maybe you have a central team who goes and creates your EKS cluster for you. You can have the EKS operator go and create namespaces, which is a construct that is within Kubernetes. So here I've created 2 namespaces. So once those are created, I go and register your cluster to EMR. So that's what you see, those dots there. So once that is done, now the data analytics team can come in and they can start submitting jobs, right? So they go and submit the job for the first namespace and another data analytics, a completely different Spark distribution. They can come in and they can run another job which runs on a different namespace. So you'll see there's a way to control job isolation so that different teams can run multiple Spark jobs in a multi-tenant fashion. They can have different permission model, and also they get the right level of resources. So we're going to go into that depth when Saravanan goes through some of his texts later in the presentation. So once these tasks are done, the jobs they get deleted by EMR, and the EKS operator can come in. He or she can delete the namespaces and unregister the EKS cluster from EMR. So that's how the whole workflow looks like. Now let me go and share my screen here. So here's the demo that I'm going to show real quick. So this is the script that I'll be using for the demo. And if you see this is the same set of scripts that I have from the presentation that I just showed. So I'm going to skip the first step where we create the EKS cluster because I already have the EKS cluster ready to use for this demo. If you go ahead and create an EKS cluster, it takes about 10 minutes. So for the interest of time, I will skip the first one. I'll run through the next step. So this step is actually optional. You don't have to create a namespace. You could use the default namespace that comes with the EKS cluster. But for this demo, I'm just going to go and create a new namespace and call it Spark Demo. So now if I do kubectl, so if I do get namespace or NS as a short form, I see that the newer namespaces are ready for me. Now, what the next step is to complete the IAM tests, right? So there's about 3 sub tasks here. The first one is to enable RBAC access so that EMR service can launch jobs or can launch pods on this EKS cluster, right? So that's the first thing we're going to do. So EKS-CTL makes it super easy for us to go and do that. So when I run the command, it says it created RBAC permission. It went and edited the file, which is AWS auth, which is a config map. So we can actually go take a look at the config map. CM is for config map. And the config map AWS auth is actually in kube system namespace. So when I say -n, which is -namespace kube system, if I go and edit that, you see that this is the configuration that we just did. So we gave permission to the role. This is the EMR service role. And we gave a username to EMR containers. Essentially, EMR containers can now start deploying jobs on this cluster. The other one that you see is, this is also another role. This is for the worker nodes, so that worker nodes can join the control plane. So those are the two that we have, but if you need to add additional set of users or roles, and we'll cover this later in this slide as well, you need to come back here and edit this file, just so you know there. So the next step is to create OIDC for EKS. Now, if you use EKS CTL, this part is already done. You can just go ahead and describe cluster, and you'll see that this has an OIDC endpoint. By the way, all of this documentation is available on EMR and EKS, and I just pick and choose EKS CTL because it just makes it easy. But if you don't use EKS CTL, you can see detailed steps there on what to do. The next step is to create a job execution role. I already have this role created. I'm going to reuse this one. So if I hop onto my console here and search for EMR containers dash job execution role, see that I've got that already here. And the next step that we will do is we will update trust policy for this job execution role. So once I run this command, I should be able to register this, update the trust policy for this job execution role. Now you see that the newer cluster that I just added is updated in this IAM. So now we have a trust relationship so that the job execution role can go and assume role in order to basically run the job. So if you take a look here, the job might require all of these permissions that we ask you to create, like S3 level permissions so that you can get, list, and put, and also for CloudWatch logs, right? So that you can store all the logging information in CloudWatch. So those are the IAM steps. So now the next step is we're going to run a command in order to register this EKS cluster with EMR service. So if I go here on the console and hop on to EMR service, go to virtual clusters, EMR service, virtual cluster, it's currently blank. So this is, if you see EKS cluster is also in Ohio. So now if I go and register this, before I run this command, let me just go here. If I register this, I should be able to get a ID, which is a virtual cluster ID. Right, so if I refresh this, I see that I just created a virtual cluster. I gave it the same name as the EKS cluster name. And also I gave the namespace. Which namespace do I want to use, right? So you see that the namespace that I just created here. If you're a multi-tenant user, the only thing that you have to do, you don't have to do all the IAM steps. It's just one time only. But if you're multi-tenant, you just need to go and create another namespace and then go and register another virtual cluster so that you can submit jobs using different virtual cluster IDs. And so the last step here is to run the Spark job, right? So now our whole configuration, our cluster is ready. EMR can call this cluster. You can go ahead and launch the jobs. What I will do before I run this, I'll go create another tab. So I just created another tab here. And I will run another command which will show all the pods that are going to be running on this particular namespace, right? Spark demo. This now, it's essentially watching for all the pods that are going to be launched. And now if I go and run this, so update the virtual cluster ID, go here and run the command. So now we are starting the job. And we get some feedback from EMR service saying I got the ID. So this is the job ID. I gave the job name as PyJob. It's just a simple PyJob. It's local. I'm not doing anything fancy here. If I go here, I should see that the job, it's submitted. So if I go and do kubectl get pods -n Spark demo. See that we've got the first one, that's the EMR. Think of that as a controller pod, and the driver pod running, and then executors that are running here. So once all of those executors actually go and perform the Spark job that I asked this to run, we should have this job completed. I'm using the execution role here that I created earlier, which actually I reused it, and it's just a Pi program, right? So it comes with the Spark distribution, so I'm just running that. And here is where I configure the infrastructure pieces, which is I say I need 2 executors. I need each executor needs to have 1 gig of memory and 1 core CPU, and give 1 core CPU for the driver. And everything else, I'm not doing anything. It's just the default. So if you hop on here on the bottom, you'll see that the job is completed and the jobs is already terminating. So if I go rerun this command, says the job is completed. You can actually go and take a look at the logs here once this is completed as well. So once, if you click on the logs, view logs, you'll see that this is essentially the EMR piece that comes in that will show that the history server, right? So you need to go and monitor how your Spark job performed, which cycles took longer. If you need to do any kind of optimization, you can do all of that here. See, this is the job that just run. So you can go click on the event log and dive into that log. But this is a Spark job that just ran that you can go look at, right? So it's a very simple demo just to showcase the power of running EMR on top of EKS. It's super easy to use. There's another piece that if you need to dig deeper into the logs, you can also do kubectl logs. So if you're a Kubernetes administrator, if you need to go and look at the logs, you can go to the driver and you can look at the same kind of logging information as well. So that's about it from my end. So that was the demo that I wanted to show to highlight how easy it is to use EMR and EKS. So let's hop back onto the presentation.
Hey everyone, I'm Saravanan Satyamurthy. So I'll go over some of the best practices with running Spark on EMR on EKS. So Peter went over the job submission process. So what you saw there was the batch job submission process. What I mean by that, you submit your Spark job, you get a job ID, and then you can track the status of the job as the job transitions from submitted to running to succeeded, right? You can do that through the AWS CLI or the AWS SDK in the programming language of your choice. Also, EMR on EKS provides an Airflow operator, and you can either use your self-managed Airflow or you can use the MWAA managed workflow for Apache Airflow, which is a managed offering from AWS. EMR on EKS also has native integration to AWS step functions. So using these orchestration tools, you can configure your DAG with dependencies between different jobs, and you can run your data pipeline. The other part of the workload is the interactive or notebook experience, where you want to have interactive way to submit jobs, look at the output, and then submit more jobs in the same session. Uh, with EMR on EKS, there is a construct called managed endpoint. So the managed endpoint uh, creates a long running pod on your EKS cluster that services the request from the notebook and executes the Spark workloads, which are the driver and executor pods, on the same virtual cluster that you had registered, like in the batch approach. There is a managed service called EMR Studio, which is in preview today, which has native integration to EMR and EKS through managed endpoint. So the demo that Peter showed you, you saw running a Pi job, which was bundled within the Docker image that was provided by EMR and EKS. When you submit a Spark job, under the hood, EMR and EKS creates the pod spec for the drivers and executors from the input you provided in the job submission API. And it also injects the configurations to pull a Docker image that EMR and EKS provides for you. So this Docker image would provide you all the goodies like EMRFS connector, AWS Glue connector, and the optimized S3 committer. So if you want to pull in your application code and dependencies, let's say in case of Scala or Java based Spark applications, you can pull it from S3 by using the S3 colon / prefix, or you can store them in a persistent volume. So you can leverage all the storage mediums that are supported by Kubernetes, create a persistent volume, and you can use the persistent volume claim to mount them to your Spark driver and executor pods. The other approach is you can use the native Spark on Kubernetes capabilities to pull the artifacts directly from repositories like Maven. So with PySpark, the options that we talked about earlier for Java and Scala Spark also applies. In addition, the Python dependencies can also be passed as a zip file, EGG file, wheel file, or a PIX file. Also, a wheel file and PIX file and EGG file can be used to pass in dynamic Python modules like a compiled C or C++ code. One thing to note, this is not supported with the zip file approach, and you can find some examples on how to do that in the link that is in the slide. So now coming to the interactive experience, we have this EMR Studio, which is a managed Jupyter notebook provided to you. You can use your corporate identity to log directly into the notebooks. This is a web-based experience, so you would not need to install the notebook server on your computers. This also lets you collaborate with peers by through GitHub. Also, you can use data pipelines with Airflow, similar to how you did with EMR on EKS. So now let's talk about a few scenarios that you can leverage using Kubernetes properties. EKS being a multi-tenant cluster, it can have a heterogeneous mix of EC2 machines distributed across multiple availability zones. There could be scenarios where you want to run your job in a single availability zone. Some of the reasons could be performance, because the data transfer is much faster within an availability zone, and also you might want to avoid the data transfer cost you incur when your pods corresponding to a single Spark application is distributed across multiple availability zones. You can do that by leveraging the Spark on Kubernetes node selector configuration. When you provision an EKS cluster, the EKS managed service attaches labels to indicate the machine type, the availability zone it is, and a few other parameters. So you can use those labels, like in this code snippet you see on the right, we are leveraging the label attached by the EKS service called topology.kubernetes.io/zone, and the value is US-WES2A. And similarly for the instance type. So when you pass in these two configurations, your job driver and executor and pods are going to be run on only those EC2 instances that has these labels attached. So there could be so the same approach you can use to run in multiple availability zones. You might need to do that for fault tolerance, or to get more capacity, or to leverage the spot instances that are available in those availability zones. The like Peter mentioned before, you have two options with an EKS cluster. Either you can use the EC2 instances through managed or self-managed node groups, or you can use Fargate. Fargate is a serverless option, so you can have a single EKS cluster which has both EC2 node groups and Fargate profile. So how you create a Fargate profile is you can leverage the EKSCTL command and say create Fargate profile. You give the cluster name and the name of the Fargate profile and the namespace. So this namespace configuration is important. If you want your jobs to run in Fargate, the namespace that was registered with the virtual cluster should be included in this namespace configuration. Only then the workloads would run in the Fargate profile. And this labels puts an additional filter to say of all the workloads that is running in this namespace, only those pods with this label should run in Fargate, right? So let's say you have 10 pods running in a namespace, and only 2 pods have this label, then only those 2 pods will be running Fargate. So once you do that, then in your job configuration, you can say in this job, for the driver pod, attach a label called place-fargate with a value serverless-demo, right? And similarly, you can do it for the executor pod as well. Once you do that, your driver and executor pods will run on Fargate, provided you have the same place-fargate and serverless-demo mentioned in this earlier command. So we'll see this in the demo. Then we'll so now you are running your application, right? You want your infrastructure to be nimble enough to scale up and down depending upon your workload needs. At a cluster scope, you can use the Kubernetes cluster autoscaler, and you can set up rules on how you need to scale up and you can need to scale down. With the EKS managed node group, the scaling becomes easier because the EKS service manages it for you, and you need to specify only the rules based on the metrics that you want to scale up and down. For self-managed node groups, though, you might need to install the termination handler to do a more graceful scaling. And with Fargate, you don't need to worry about the scale in and scale out configuration. The Fargate takes care of that for you. So this, you can look at it like a serverless option to scale in dynamically. So now at a job scope, when a Spark job is run, your Spark job might need, let's say, 20 executors only for 10% of the time. For the 90% of the time, it might not need so much of resources. So you can use dynamic resource allocation to do that scaling. So with Fargate, we recommend you to review the pod sizing and storage limitations to see if your workload fits within those so that you can leverage Fargate. So this is an example of the dynamic resource allocation, which is used to scale within the job scope. So when you run your job, you can enable this at a job level. So you have 10 jobs, you can enable this for only those jobs that need them. So with Spark 3 provides this capability called dynamic allocation with shuffle tracking. So this is a way to enable dynamic resource allocation with Spark on Kubernetes, and it is available from Spark 3. So in this configuration, you specify the initial number of executors. So when the job starts, it starts with 10 executors, and then it can scale up to a maximum of 100 depending upon the number of pending tasks. Once there are no pending tasks and your executors are idle, after a configurable amount of idle time, the driver can terminate the executors provided the executors don't have any shuffle data. So with traditional Spark clusters or Hadoop clusters, you have the HDFS, which is a storage layer, and the compute together in a single cluster. With EMR and EKS, you have the separation between compute and storage so that both of them can scale up and down depending upon your needs. When you run a Spark job with EMR and EKS, we talked about how EMR and EKS creates a pod specification for the driver and executor pods based on your input request, right? So when it's generating the pod specs, it creates empty DAR, which points to the storage in the EKS worker node. And the scope of this storage is ephemeral, and it corresponds to the life cycle of the pod. So when the pod completes the storage, whatever the data you had in the storage in the EKS worker node is lost. So this is good for a few use cases, like you want to store your shuffle data or you want to spill to disk your cache data. This is perfectly fine. For your persistent storage needs, you can use S3 using the S3 colon slash slash prefix. With EMR and EKS, the Docker image contains the optimized Spark runtime, which also has the EMRFS component bundled together. This EMRFS has a lot of optimizations in how it commits to S3. So you can also leverage the power of Kubernetes persistent volumes. You can use EBS, EFS, or an FSX. So EBS, you can create a persistent volume. It can be a dynamic provisioning or static provisioning. And then it is mostly used when you want to attach it to a single pod. If you want a storage that is distributed and scalable, you can use either EFS or FSX. This lets you share your storage across multiple pods within a same job or across multiple jobs. So you have a data pipeline which consists of 5 jobs. And let's say job 1 outputs data that is consumed by job 2 and so forth until job 5, which produces the final data that needs to be persisted back to S3. So for this intermediate data that needs to be shared across jobs, you can mount the same FSX for Lustre across all these jobs, right? And one tip, you can use the in-memory caching feature with FSX for Lustre for higher performance. And FSX for Lustre can also uh, provide you scalable storage with respect to the capacity and IOPS. So I would highly encourage you to take a look at FSX for Lustre for your storage needs. This is a managed offering from AWS. It also gives you a POSIX interface on top of the S3 objects. So there are two types, the scratch and persistent. So at a high level, the differences are scratch, you don't back up the data, and if an instant fails, it's not replaced. This is very good for those needs where you can recreate the data even if it is lost. Persistent option can be used where you want to make sure your data is not lost because creating those data might require a lot of compute time or might not even be possible. So now let's talk about how do you do monitoring logging with EMR and EKS. So in the demo shown by Peter, you saw how you can look at the logs, the Spark history server, and leverage kubectl So with EMR and EKS, the driver and executor pods also run a Fluentd sidecar container. This Fluentd uh, would scrape the logs and metrics from your Spark driver and executor pods. The Spark event logs are pushed to AWS old S3 bucket every 30 seconds. And when you go to the EMR console and you click on the view logs, there is a Spark history server that gets spawned dynamically, and it loads these event logs and you can view the metrics. So this lets you look at the Spark application metrics long after the job is completed. And if you have your custom monitoring solutions like Splunk, Datadog, you can run those agents as a daemon set on your EKS cluster, and they can scrape the metrics from the driver and executor pods. If you already have a Prometheus environment set up, you can use Prometheus to scrape the metrics as well. So the logging part, as we saw in the demo again, you can use kubectl. The scope is ephemeral because the pods would be terminated and then you will no longer be able to see logs. So what EMR and EKS provides using the same Fluentd sidecar container we saw earlier, it scrapes the logs from the std out of the driver and executor containers and ships it to S3 and CloudWatch. The S3 prefix to which the logs needs to be pushed is got from the jobs definition under the monitoring configuration section. And the same thing for CloudWatch as well. If you have your own logging solution like Splunk or Elk Stack, you can use the same approach. You can run the agents as a daemon set and scrape the logs from the std out of the driver and executor containers. So here is a example, a code snippet on how you can specify the configurations at a job level using from the monitoring configuration section. So this is a architecture diagram of how EMR and EKS does that. You submit your job from a CLI or SDK. The Amazon EMR and EKS control plane gets the request, spawns the job in the EKS cluster. Your EKS cluster can have a node group of EC2 instances and also Fargate in the same cluster. And one EC2 instance can have multiple pods running, and this one pod contains the Fluentd sidecar, and the other container could be your driver, executor, or job runner. So by out of the box, the Fluentd container ships the Spark event logs to the AWS whole S3 bucket, the driver, executor, and job runner logs to the S3 bucket that was specified in the job definition, as well as to the CloudWatch specified in the job definition. So when you go to the AWS Management Console, go to the EC2, and you click on the View Logs button, you get a managed persistent Spark history server, which loads the metrics from this S3 bucket. So if you have third-party logging or monitoring solutions, like mentioned earlier, you can run the daemon set on the EKS worker nodes and ship it to here. Right? And you can also use a log pipeline optionally to scrape it from S3 and push it as well. So EKS being a multi-tenant cluster, for you to access your EKS cluster, you need to have the RBAC permissions. So to do that, if you are trying to access your EKS cluster with an IAM role that is different from the one that used to create a cluster, you can edit the AWS auth config map that Peter showed in the demo, either through the EKSCTL command, or you can use the kubectl to do that, and you can access your Kubernetes API server. Then you have the EMR and EKS identities. So this is the IAM role that was used to create the virtual cluster. Then you have the IAM role with which you submit the job, right? So this would be the one where you hit the API, the start job run API provided by the EMR and EKS service. Then you have the job execution role, which is provided within the job definition. This is the IAM role which the driver and executor pods use to talk to other AWS managed services like S3, DynamoDB. So here you can see that in the job flow diagram. So the EKS operator can use kubectl to talk to your EKS cluster. If it is a different IAM role, you change the config map, the AWS auth config map. Then this IAM role, the EKS operator uses to create virtual cluster needs to have appropriate policy to do that. And that is in the EMR getting started guide. And here you have a data engineer who uses the IAM role to invoke the API. We call it the job submitter IAM role. And then when the Spark driver and executor pod runs on the EKS cluster, they use the job execution role to talk to other AWS services. With running on a multi-tenant cluster, you can segregate or make sure the pods that can talk to each other are bounded by a network Calico network policy. You can also enforce authentication between the Spark driver and executor pods using a shared secret. This can be enabled using spark.authenticate configuration. You can also configure the job to using Spark network crypto enabled configurations to encrypt all the in-transit communication between the driver and executor pods. So a single EKS worker node can have pods from multiple jobs co-located. So you want to make sure the data that is filled by one pod is not exposed to other pods. So you can use the spark.io.encryption.enable configuration so that the driver and executor pods uses a secret to encrypt the data before it persists to disk. And that secret is created dynamically once per application. So once the pod dies, the secret is no longer available. So now let's look at a short demo. So I prefer this style of invoking the API where you create a JSON file. And here what we are going to show is the dynamic resource allocation, the DRA feature with shuffle tracking. So we are hitting the EMR 6.0 latest version that corresponds to Spark 3.1. And here, these are the configurations that is interesting to us. We saw this earlier in the slides. So now let's go ahead and invoke this command. So once you hit the API, you get the job ID. And this is the virtual cluster ID that was targeted. And this is the on for the job run. And here, when you do AWS STS get caller identity, so now it says that this is the IAM identity that was used to invoke the start job run API, right? So now let's go and look at the AWS console. So here you have the job that is in submitted state, right? And here I'm gonna look at the AWS dashboard. So here you can see there are 10 executors coming up. So going back to the job definition, we said initially start with 6 and you can scale until 100, right? So it started with 6 and it's scaling up to 11 executors. So it's going to keep scaling and then it's going to scale down and eventually the job is going to complete. Okay. So now you might also, while you're waiting for the job to complete, you might also optionally want to enable debug logs, right? So you can do that using this classification called the Spark log4j, and you can say what is the debug level that you need to have. So this would output the debug logs. And we'll also see about the node selector. So as we saw earlier, here we say Kubernetes.io zone. I want to run in US West 2D. So here the job runner came, right? So as you can see, the job runner would spawn the driver and the executors. So what I want to show you here is you can click on the driver. So this is similar to the kubectl describe pod. Here you see that it is scheduled on this EC2 machine, and this has the zone as US West 2D, right? So it would schedule the driver and executor on only those nodes that have this label. So when you are creating a EC2 node group, you can put in your custom labels. So if we go to the EKS console, you go here and go to compute and you go here. So here, when you can create any labels that you need, and you can leverage those labels and values when you submit a job. Like instead of Kubernetes topology kubernetes.io, you can say spark.kubernetes.node.selector.key1 equal to value one, and make sure that key one and value one are updated here. So now let's look at the Fargate example. So I create a Fargate profile, and this Fargate profile is configured to run the workloads that is targeted to the demo namespace. So this is the namespace I registered my virtual cluster. And within that, you can have an additional filter to say of all the pods running in the demo namespace, only those pods with the label place-fargate and value serverless-demo run it in this Fargate profile, right? So let's see an example of how to do that. So here we see that I need to label my driver and executor pod. So you can use this configuration to place this custom label place-fargate. So when I run this job, you'd see that this is running in Fargate as opposed to the EC2 nodes. So let's run this. Look at the EKS dashboard. Let's go, if we are in our demo namespace, let's go to pods. So we have this new job runner that came up. So you see here, this is like one of the highlights with EMR and EKS. Your job startup time is pretty fast. You don't need to wait for a cluster to start up and then run your job. Rather, the job runs as soon as your Docker image gets downloaded. So while it is running, I want to show a few other things which are interesting. So typical debugging sections. Let's say you run your job, right? And you don't find your job running. So what you can do, you can go here and you can say kubectl get pods -m demo. So here, this shows all the pods that are running in your namespace that you registered. So you can also, if a pod is in a pending state and it's not running, right? So what you can do kubectl describe pod, and you can say, let's say I want to look at a pending pod, right? So this is pending. So I'll go here and copy this, and it is in namespace demo. So this gives you a pod spec. So this is a pod spec that EMR and EKS creates for you. And here you see, you look at it's scheduled to the Fargate scheduler. Now you have a Fargate provision node on the fly, and it's pulling the image. We are done with the demo for Amazon EMR and EKS. Now let's look at the pricing. Pricing for EMR and EKS is based on the resources that are used by your pods, and that include your job runner, driver, and executor pods. You don't get charged for the virtual cluster being up and running. You only get charged for the duration of the time your job is running. And it is based on the vCPU and memory resources that are consumed by your job. So this will be in addition to the billing for EC2 storage and EKS. So these are some very good resources. This is you have the EMR and EKS getting started guide, which has the steps that we talked about in this demo. and how to configure your IAM policies, access control. You have the EMR and EKS best practices guide. You have the EKS best practices guide and EKS workshop. So these are very good resources for you to get started with EMR and EKS. Thank you.